Alright, so here we have question 5 of the November 2018 grade 12 CAPS math exam, paper 1. Alright, so question 5, another graphing question, same as in the previous question. Question 4 was also to do with graphs, with inverses, and this is, we can see a hyperbola that we have to answer questions about. Okay, so let's just write down the equation of the graph. Let's say f of x equals negative 1 over x minus 1. So we can see it has the form of a hyperbola. Now in general, a hyperbola formula is y equals a over x plus p plus q. Obviously you can make the different letters. Sometimes they put a k, and we usually use p and q for these ones. Okay, and in a hyperbola, and we know the asymptotes, so the asymptotes, let's just write that word down, asymptotes. Okay, so the asymptotes of hyperbola of the form x equals negative p, that's the opposite sign of that, and y equals q. Those are the asymptotes, the two straight lines, the horizontal and the vertical asymptote. Alright, and a, what does a tell us about the graph? Well, if a is positive, then we know it's in the first and the third quadrant. If a is negative, it'll be in the second and the fourth quadrant. Second and the fourth quadrant. Okay, so that's a quick summary on how hyperbolas work. Now let's get into the questions. 5.1. Okay, write down the domain of f. What does domain mean? Well, domain is all the values that you can put into the equation and still get an answer. Right? So it's all, in our case, all the x values for which this graph exists. Okay, so how can we see which x values will work for this? Well, it's easier to check which ones won't work. Right, so ones that won't work are values where we divide by 0, or values where we have the square root or any even root of a negative number. No roots involved here, so we can just check what will give us 0 at the bottom, because that won't work. Right, so we know that x cannot be, well, at least let's start with x minus 1. The denominator cannot be 0. So that means x cannot be 1. So x can be anything but 1. So we want to write x can be any real number except 1. Okay, so that is the domain of f. X is any real number except for 1. Alright, let's get to the second question, 5.2. Write down the asymptotes of f. Asymptotes, we just saw, that's going to be x equals negative p. So in this case, x equals the opposite sign of that, so x equals 1, and y equals the value of q. In this case, we don't have anything, right? So it's 0. Y equals 0. Straightforward. 5.3. 5.3. Okay, sketch the graph. Okay, let me just draw a system of axes here quickly, and then we'll sketch it on there. So system of axes, let's label it, always important. Y-axis and x-axis. Oops. X-axis. And then they say showing all intercepts with the axes and any asymptotes. Okay, so let's first draw in our asymptotes. I'm going to use a dotted line for that, and I'll do the asymptotes in blue. Okay. So we know x equals 1. That's going to be one of our asymptotes. So x equals 1. Going to be an asymptote, and y equals 0. So y equals 0 is just right here. So that's going to be another asymptote. You can't really see that, but that's fine. It's on the x-axis. Okay, then we also need any intercepts of the axis. So how do we find an intercept? Let's start with the y-intercept. Let me first change this back into standard. Okay, so to find the y-intercept, what do? The y-intercept is when x is 0, right? So we make x 0. So that'll give us y equals negative 1 over 0 minus 1. So y equals negative 1 over negative 1, which is 1. So y equals 1 is going to be one of the intercepts. Now to find the x-intercept, we make y 0. So to find the x-intercept, we say y must be 0. Okay, so if we say 0 equals negative 1 over x minus 1, multiply both sides by x minus 1 to get rid of the denominator. So 0 times x minus 1 equals negative 1. Now 0 times something is 0. Right. So we see there's a problem here. What is the problem? Well, the problem is this graph does not exist when y equals 0, right? That's an asymptote. That's an asymptote. So it won't have any x-intercepts. It's impossible. So that's why we get an error here. And I just wanted to show what it would look like so you don't get confused when you see this in the exam and think mathematics is broken. Right? So this is impossible to have this. Okay. So we only have the one intercept. We see our a value. We said here if a is negative, the graph is in the second and the fourth quadrant. And we see our a value is negative, right? So it does make sense that we'll have it in the second and the fourth quadrant. So in this quadrant, there we've got part of the graph, and the other part is in here. Alright, now we just have to label everything. So this is x equals 1. This asymptote is y equals 0. This point here, the y-intercept, is 0, 1. And there's no x-intercept. So there we have it. We've drawn our asymptotes. We found our intercepts. There was only one in this case. And we've drawn our graph in the correct quadrants. Good. Question 5.4. 5.4. Let's do that over here. Okay, so now I ask, for which values of x will x times f prime of x be greater or equal to 0? Okay, so what is f prime of x? This, remember, means differentiate. And what does differentiate do? It gives us the gradient. It gives us the gradient. Okay, so this question asks, where is the x value multiplied by the gradient of the graph greater or equal to 0? Where is it positive? Okay, so this might seem a little bit complicated, and we can do it in a complicated manner. I mean, the algebra would be a little bit more difficult than what would be a straightforward method by just checking on the graph, because we've already drawn it. So let's see, what do we have to check? Right, let's actually first, before we do that, let's just see, how do we know if two things multiplied together are positive or negative? Right, so if we have a positive times a positive, what is that? That is a positive, right? If we've got a negative times a negative, let me just rewrite that. So a negative multiplied by a negative, that is a positive as well. So we know both has to be positive, both have to be negative. If we've got a positive times a negative, that's a negative. Negative times a positive, that's a negative. So we're looking for this, where x is positive and the gradient is positive, or where x is negative and the gradient is negative. That's what we're looking for. Let me erase this part, because we don't really care about this. We're not looking for that. We're looking for positives. All right. So let's split the graph into all the different sections that we need to look at. So any intercepts with any axes, or where x changes from negative to positive. So we're going to draw a line there. Whoa, that's quite thick. Let me just make it a little bit smaller. Right, this should be better. Okay, so we need to look there, and we need to look there. So we look at all three of these sections. If the graph went through the x-axis somewhere, we'd also draw a line there. Let's say the graph intersected there. So you just want to split the graph into all its different sections. And now you just look at all of them. So first, let's look at this section here. So this is 4x less than, and we can include the 0, less than or equal to 0. So for those x values, the x value we know is negative, right? All the x values here are negative. So x is less than 0 or equal to 0, so that's negative. Right. What about the gradient? What does the gradient of the graph do here? The gradient is positive, right? It's an increasing function. The gradient is positive on this side. So the gradient is positive. Okay, so a positive and a negative make a negative, so that's wrong. We don't want this value, this part. Now let's look at this middle part here, that part. So between 0 and 1. So now let's say for x, between 0 and 1. Between 0 and 1. Okay, so here, obviously x value between 0 and 1, so x is positive. The gradient, what about the gradient of the graph here? The gradient is positive, right? It's increasing. Gradient is positive. So then a positive make a positive. So this part works, that's correct. And one more section to check, all the values to the right of 1. So for x greater than 1, what do we have there? Obviously for x greater than 1, x is positive, right? X is greater than 1, which is positive. So x is positive. What about the gradient? Let me just write down the gradient. So the gradient over here is also, we read the graph from left to right, also increasing, right? The gradient is positive. We're not looking for the graph, but the gradient. The graph would be negative because it's below the line, but the gradient is positive. It's increasing. So the gradient here is positive. And a positive make a positive. So this also works. We like that. This part also works. So what works? Everything bigger than 0, except, we need to look at this one, except that x equals 1. What happens at x equals 1? So let's just quickly check at x equals 1. What happens there? So is x bigger than 1? Yes. Bigger than 0? Yes. X is positive. What about the gradient? What is the gradient when x is 1? Well, the graph doesn't exist there, right? We just found it at the domain. The graph does not exist when x is 1. So it doesn't have a gradient. So this we can ignore. That is not part of our solution. So it's x bigger than 0 all the way this side except at 1. So our final answer would be x is greater or equal to 0, but x is not 1. So 1 doesn't count. So that's it. That's our answer. You could also write it in another interval notation. You could also say x is an element of all the values between 0 and 1. But 1 is not included, not included. And then again, everything from 1, not included, all the way to infinity. And infinity is also not included. So this is another way you could write it. This is probably the most common way to write it. Alright, and that is it then for question 5. Good, and I'll see you again for question 6.